Today we are going to study choppers, which is also known as DC to DC converter. Contents are as follow. First of all, we will go through the principle of chopper operations, waveforms related to it, and mathematical equations. So a chopper is basically, as I have already told, it's a DC to DC converter, but the thing is, it's a conversion from fixed DC to variable DC. The input side, it is a fixed DC, and at output we will get a variable DC. It can be done in two ways. As we can see, the first way is given here. Now in the first way, it is given that DC is first converted into AC through a inverter, and that AC is again converted into AC by a transformer action, step up or step down, and that step up or step down AC is again converted into DC through a rectifier operation. Now in this procedure we can see that it's a two-stage conversion, that we require lots of converting states, DC to AC, then again from AC to AC, and then again AC to DC. So it is costly. Of course, we require lots of conversion states, so it's costly. Also, it is bulky and less efficient. So we will see that what is more efficient way to convert a DC, fixed DC to variable DC. Now a chopper is a device which convert fixed DC to variable DC. Actually, by definition, it is a high speed on-off semiconductor switch. So chopper is a high-speed operating switch. Now we can see an elementary chopper circuit here. Now in this circuit we can see there is an input Vs, there is a switch SW, and there is an output voltage denoted by V0. Now, as by our definition, there is a DC input, there is a output DC, and there is a switch SW, which can be any switch. We can choose it as a MOSFET or IGBT, anything as per our requirement. Now here we can see there is FD also here in the. Now this FD is freewheeling diode. In earlier classes also we know what is the role of freewheeling diode. Let's start analysis of this circuit. So as soon as the switch SW is turned on, this switch is turned on, the input side is get connected to output. Now by the Kirchhoff law, as Kirchhoff voltage law, we can see that Vs is equal to V0. V0, that is output voltage. What happened? We have just closed our switch SW and input side get connected to output. Now by the Kirchhoff voltage law, this is the equation we will get. Vs is equal to V0. When the switch is turned off, simply when the switch is turned off, now there will be no current flowing from input side, although the current will be carried through this inductor L. Now as earlier, when the switch was turned on, it gets charged, and now it will release its energy through this freewheeling diode path. Now if we apply Kirchhoff voltage law in turned off position, V0 is equal to 0. Now we have two equations. First, when the switch was turned on, Vs, which was equal to V0, and when the switch is turned off, V0 is equal to 0. Now we have two equations. Now from the waveforms it is clear. Now this is input voltage waveform, this is output voltage waveform, and this is output current I0. Now you can see that as input side is a fixed DC, a constant voltage we can see, which is of magnitude Vs. Now output voltage is get chopped. Now switch SW is turned on for period of T on, and it is turned off for period of T off, as you can see in the waveform, turned on and turn off period. So when the switch is turned on by the Kirchhoff voltage law, Vs is equal to V0, and when the switch is turned off, V0 is equal to 0. Now we can figure out in this waveform that V0 is equal to V0 when the switch is turned off. Now for the similar mean, we can trace out the current through the inductor and load L. We can see that current attempts a maximum value, and then after it decreases to a minimum value, I max and I min. So these are the basic voltage waveforms of output and current waveforms. Now we will figure out what are the equations which are relating output voltage to input voltage. Now as by the waveform, you can see that V0 is equal to Vs for turn on period. Now this is a periodic function. V output is a periodic function whose period is T. And what is the value of T? The value of T is T on plus T off. Now this is the value of T, which is the time period of that periodic waveform, and its frequency can be f, which is again equal to f is equal to 1 by T. So V0 is equal to, from the waveform we can easily figure out that V0 is equal to turn on upon turn on plus turn off. Now this turn off plus turn on, which is also equal to T, that is time period. So V0 is equal to turn on upon T multiplied by input voltage. Now V0 is equal to alpha Vs. Now this alpha or D is known as duty cycle. Now duty cycle, what is duty cycle? That is turn on upon total time period. What time period of this output voltage? You can see this output voltage waveform is a periodic. This is a periodic function whose period is T, and that T is equal to turn on plus turn off. So finally we get for the elementary principle that there was a fixed input voltage Vs, and we have now a variable output voltage V0. How it is variable? That we can always change the value of alpha by the changing value of turn on or turn off. So now output voltage is a variable quantity. So that's all for today. If you have any queries, you can mail me on this email ID. In the next class, we will learn about buck converter, which is also known as step down chopper.